Welcome my dear student, welcome again to my channel Physics JN, the specially made for joint and NEET। तो बच्चों आज हम सीखेंगे कि मिरर का जो स्फेरिकल मिरर है उसका जो इमेज डिस्टेंस, ऑब्जेक्ट डिस्टेंस एंड फोकल लेंथ, इसके बीच में क्या रिलेशन है। इमेज डिस्टेंस, ऑब्जेक्ट डिस्टेंस एंड फोकल लेंथ, इसका जो रिलेशन है वो आज हम जानेंगे। ओके, तो इन जनरल दिस रिलेशन इज रिटन एज 1/v प्लस 1/u is equal to 1/f, where v is the image distance from pole, u is the object distance from the pole, and f is the distance of focus point of this pole. Okay, so in many books you are known about how to prove this. Suppose this is a concave mirror M1 M2, and between C and infinity an object is placed. So a ray is passing incident parallel to the mirror, passing through the principal focus point, and another ray which is just go or pass through the center of curvature, incident reflected back along the same point, and an image. Suppose this is the image is AB, so here the image A dash B dash is formed, and we can take the two triangle, we can draw a perpendicular from this, and we can make proof that the two triangles are congruent, and we can make the relation 1/v plus 1/u equal to 1/f. But today we will do some different method. Okay, so very short and easy but different method. So शेष तक देखते रहिए, आखिर तक देखते रहिए, डोंट स्किप द वीडियो। ओके, सो सपोज दिस इज एन कॉन्केव मिरर ऑफ फोकल लेंथ एफ। तो बिफोर गोइंग टू दिस वी कैन टेल अबाउट सम द साइन कन्वेंशन, we can know about the sign convention. Which is sign convention? Number one is all distance are measured from pole. All distance, any distance are measured from pole. Number two, the distance along the incident ray, the distance measured along the incident ray is positive, and opposite to incident ray is negative. All the distance are measured from pole, and the distance along the incident ray which is measured along the incident ray from pole is taken as positive, and opposite to the incident ray is taken as negative. Number three, the height on the principal axis or above the principal axis, or the height above the principal axis is positive, and lower the principal axis is negative. So before going to prove the relation, we can first know this sign convention formula. Suppose this is an concave mirror M1, M2. Now, suppose a point object O is taken on the principal axis. The ray from the point object O is incident at a point A, then passing through the point F along this point. So, if this is F and this is the center of curvature, then we add the center of curvature to the point A. So, this is the angle of incidence theta, so this is angle of reflection also theta. This angle is alpha. The angle made by the center of curvature, the angle made by the radius of curvature and the principal axis is beta, and this angle, that is the reflected ray and the principal axis, is gamma. We can draw a perpendicular from A to the principal axis, which is known as A dash, or which is known as, suppose, P dash, and P is the pole. Okay, so from a point object O, a ray is incident at point A, then goes along the point AE. The angle of reflection is theta and angle of incidence is also theta. The ray, incident ray, makes angle alpha with the principal axis. The reflected ray makes angle beta, makes angle gamma with the principal axis, and the radius of curvature makes angle beta with the principal axis. Now, from the figure we can say that alpha plus theta equal to beta. Alpha plus theta equal to beta, because the sum of the interior angle of a triangle is equal to the exterior angle. So, alpha plus theta equal to beta. Similarly, we can say that beta plus theta is equal to gamma. So, if we take alpha plus gamma, we can get 2 beta, because gamma equal to alpha equal to beta minus theta and gamma equal to beta plus theta. So, if we add alpha plus gamma, we can get 2 beta. As alpha beta are very small angle, so we can say that alpha is nearly equal to tan alpha, gamma is nearly equal to tan gamma, and beta is nearly equal to 2 tan beta. When angle is very small, then tan alpha nearly equal to alpha. So, put the value of tan alpha. What is the tan alpha? Alpha. So, from triangle AOP dash, this is P dash, so P and P dash, and also P is related nearly to P dash. Okay. So, what is the value of tan alpha? Perpendicular by base, that is AP dash divided by P dash O. What is the value of tan gamma? AP dash by P dash F, AP dash by P dash F, and 2 into tan beta means tan beta is from P dash AC triangle, AP dash by P dash C, AP dash by P dash C. As P dash nearly equal to P, so we can write that AP dash by PO plus AP dash by PF equal to 2 AP dash by PC. Now, according to sign convention, all the distance measured from pole, so OP or PO equal to minus U. According to sign convention, we can write that. इसको लिख लिया? So, according to sign convention, we can write that PO equal to minus U, PC equal to minus R, and this point, suppose this point, the image is F. Here F is not focus point, but the image format F. Okay. So, P dash F, or you can say the name is I. So, as it is confusing between F and I, so you can write it as I. So, pi equal to minus v. So AP dash by PO, AP dash by PI. So AP dash is cancelled. So 1 by PO plus 1 by PI must be equal to 2 by PC. Okay. Put the sign convention. Minus 1 by U plus minus 1 by V equal to minus 2 by R. Minus 1 by U plus minus 1 by V equal to minus 2 by R. Now if U equal to infinity, that object is at infinity, so we can get that 1 by V equal to 2 by R. We can get 1 by V equal to 2 by R. But we know that if the object is at infinity, the image formed at focus. So we can say that 1 by F equal to 2 by R. So R equal to F by 2. From this relation, we can also prove that R equal to F by 2. So, and also from this relation, we can get that 1 by U plus 1 by V becomes 2 by R equal to 1 by F. So this is the relation between object distance, image distance and focal length for a convex mirror. Sorry, for a concave mirror. For convex mirror, you will do the same. Next we go with the magnification. Okay. आज सिर्फ थ्योरी कराऊंगा, इसके बाद the next day we will go with the problems. So don't miss and please subscribe my channel for your next video. Okay. So now we go with the magnification. What is magnification? Magnification. Magnification is nothing but how object is enlarged or diminished with relative to the image size or image distance. So magnification may be three types. Number one is transverse magnification. Number two is longitudinal magnification. And number three is aerial magnification. Okay. At first we go with transverse magnification. When an object is placed perpendicular, when an extended object is placed perpendicular to the principal axis, then the image formed by the object and the ratio of the object distance by image distance or of image height, the ratio of the image height m equal to image size by object size. Or we can say that here we can go with transverse magnification. When his object is placed perpendicular to the principal axis, or it is said that image distance by object distance. Okay. So if a ray is passed from this and parallel to the principal axis, this is passed through the F. Suppose a ray O dash, a object is placed in front of a concave mirror and a ray from O dash is incident parallelly to the principal axis at point A and pass through the F. Similarly, another, if this is the center of curvature, we know that the ray passing through the center of curvature without any deviation and reflected back normally along the reflected by normally along the same direction. If any ray incident on the mirror through the or passing the center of curvature, then there is no deviation occur, it will reflected back along the same path. So if we these two reflected ray, that is A, suppose AS and suppose OD, so the reflected rays DO are intersect at this point, we can say it the image distance I. So it is say I dash, and if we draw a perpendicular I, so an inverted image is formed. Now M is the, now what is M? M is the image size by object size. What is image size here? Image size is I dash, but this is the the lower portion of principal axis. So according to the sign convention, it is minus, we can say it minus HI. HI is the size of the image. Object height is HO. So image distance, here image distance is PI. Again, this is the opposite to the incident ray, so we can say that as minus V, and the object distance is also OP, is known as minus U. So the transverse magnification M must be written as HI upon H0 equal to minus V by U. This is the basic formula of transverse magnification. Okay, you can find out this by using proper sign. Here you can using proper sign of U and V. This is the basic formula, but using proper sign of minus V by U. Okay, so there is a similar relation between M and U, that is M equal to F by F minus U or F minus V by F. This is the direct relation between magnification and focus and object distance and focus and image distance. Here we cannot find out the V. If V is not known, then also we can get the magnification F by F minus U or F minus V by F. Okay. Now what is the longitudinal magnification? If any longitudinal magnification is if any particle or any object lie along the principal axis, then the height or size of the image and object is called the longitudinal magnification. If the object is placed transverse or perpendicular to the principal axis, this is known as transverse magnification. If the object is placed along the principal axis, then it is known as longitudinal magnification. Now longitudinal magnification is known as M equal to minus VF minus VI by UF minus UI. VF is the length of the object along the principal axis, VF minus VI, and length of the image is UF minus UI. If the object is very small, then it is known as minus dV du. So dV du is must be equal to, then if this is said that longitudinal, that is ml, ml must be equal to v square by u square. So the length of the image, that is I, length of the image, you can say it hi. Hi equal to v square by u square into h0, that is the length of the object. ml equal to v square by u square. Next we go with aerial magnification. Aerial magnification is valid for two-dimensional object. Aerial magnification is valid for two-dimensional object. Minus dV du equal to v square by u square. How can we get it? 1 by v plus 1 by u equal to 1 by f. Take differentiation, minus 1 by v square dV du minus 1 by u square equal to 0. Because f is constant for a particular mirror and the constant term derivative is 0. So we can say that minus dV du is equal to v square upon u square. Okay. Again, if a two-dimensional object is placed in front of a mirror, two-dimensional object, suppose the length of the object is L and breadth is B, and it magnifies an object m times, that is the length is breadth is MB and length is ML, then also the areal magnification is written as MA, that is A for areal, areal magnification must be written as the ML, size of the image, into MB divided by original size of the object LB. So M square LB by LB, or M square A is the area of the object by A. So we can get M square. So areal magnification is equal to square of transverse magnification, and here also the longitudinal magnification is, the magnitude of longitudinal magnification is equal to the M square. Okay, and also here the areal magnification is the square of the transverse magnification. So in this way you can know that how you can prove the relation between object distance, image distance and focal length of a spherical mirror, that is concave or convex. And also we can know the three types of magnification and how can we solve this. In the next day we will go with problem and according to the sign convention, which is very important. So don't miss the video. If you like my video, please subscribe my channel so that I can inspire by you, and write in my comment box your problem, which chapter you get difficult to understand. I will definitely solve it and try to solve it. Thank you very much.